All right. Hey, everybody. We are in lesson 3-7 of the Tennessee Revealed Geometry. So we are starting to talk about parallel lines cut by a transversal. All right. So you're going to have a lot of vocabulary in this lesson right here. We know that parallel lines are lines that never intersect each other. But what you may not remember is that they have to be in the same plane. Because if they're not in the same plane and they don't cross, then they're skew lines. We're going to see an example of that in just a minute. All right, you can also have parallel planes, transversal. I'm going to go through all of these words right here. You've heard interior and exterior before. The consecutive, interior, alternate exterior, and corresponding angles are all going to be probably new to you. All right, we're going to learn again what parallel means. A couple of things to be aware of. This little symbol right here, it looks like a skinny 11. That's the symbol for parallel. Now, if you're looking at a figure over here, these arrows that are filled in, when they are one, those lines are parallel to each other. You can also have double arrowed lines if you have two sets of parallels. So in this figure, line JK and line LM are parallel to one another. That's what that skinny 11 means. All right, skew lines are lines that don't cross each other, but they're not in the same plane. So they're not parallel, they are skew. Here's an example of what it might look like. Line L, which is in plane A, and line M, which is in plane B, are skew lines because they don't intersect and they're not in the same plane. Parallel planes, like plane A and plane B, here's a view of what that looks like. All right. All right, so let's get down to an example here. Identifying parallel and skew relationships. All right, in example 1, part A, all lines skew to BC. Well, here's BC. Skew means it's in a different plane and they don't intersect. All right, so they give us AF, which goes up and down, not in the same plane. And in fact, it doesn't have a B and C in it, so keep that in mind. DE, not in the same plane, does not have a B or C in it. All right, FG, going this way, not in the same plane, doesn't have a B or C in it. So it looks like the next one's going to be HE. So FG and EH. All right, so let's see. Go over here. Looks like I'm going to need to go to geometry so that I have something on top. I need a line. I can't tell if that's a line or not. EH. All right, it looks like I picked the wrong one. That's the segment. So make sure you pick the one that has a line on it. Go back to geometry. And there we go. This one right there. EH. All right. Next one, section B. All lines parallel to EH. Well, for you visual people, there is EH. Parallel would be AB, CD, and yep, you guessed it, GF or FG. Geometry. All right. FG. All planes parallel to plane DCH. Well, let's see. DCH is this right side of the cube over here. And I need a plane that is parallel to it. Well, right side will be parallel to left side. So we need to go with ABG. And that's the only one. Okay, let's get into the word transversal. You guys, basically a transversal is a line that intersects two or more lines. T would be a great example of a transversal. It is intersecting line Q and line R. Now, Q and R do not have to be parallel for it to be a transversal, although they can be parallel. So this figure we saw up here, this line LJ is your transversal because it's intersecting line LM and line JK. So this is your transversal when the lines are parallel. And this will look like line T is your transversal when Q and R are not parallel. Now that makes a big difference when you're talking about congruence of angles. So we'll talk about that I'm sure, in a few minutes. Okay. All right, you guys, so let's get into it. Interior and exterior. We have learned that points on the interior are inside. So when we're talking about angles, it basically means angles inside. All right, so let's look at this. We're looking at line Q and line R. Our inside angles are the ones that are between lines Q and R. So 4, 3, 5, and 6 are interior angles. Exterior angles are the angles that are not between lines Q and R. 1 and 2 is above Q, not between Q and R. 8 and 7 are below R. They are not between Q and R. So 1, 2, 8, 7 are all exterior angles. Consecutive interior. Well, first off, you have to talk about angles that are inside the two lines, Q and R. 4, 3, 5, and 6 are interior angles. But consecutive means on the same side of the transversal. 4 and 5 are both on the left of the transversal. That makes them consecutive interior. 3 and 6 are both on the right of this transversal. That also makes them consecutive interior. So our consecutive interiors are 4, 5, 3, and 6. Alternate means on different sides of the transversal. So you're still talking about interior angles. 4, 3, 5, and 6 are interior, but now you're talking about opposite sides of the transversal. Now, my students like to say, oh, 4 and 3. No. Those are adjacent angles. I'm talking about 4 with 6. Those are alternate interior. 3 and 5 are alternate interior. All right. Alternate exterior. Okay, first off, they have to be exterior angles. Remember, that's 1, 2, because it's above Q. 8 and 7, because it's below R. They are not between. But alternate means on different sides of your transversal. So alternate to 1 would be 7. And alternate to 2 on the other side of the transversal would be 8. And again, if you're a teacher, make sure the students realize that it's not 1 and 2. Those are adjacent angles, not alternate exterior. 1 with 7, 2 with 8. Same thing with 8 and 7. Those are alternate angles. All right, corresponding angles. These are angles that are sitting in the same position of their cluster. And I'm talking about 1, 2, 4, 3, compared to 5, 6, 8, and 7. Now, they have to be on the same side of the transversal. So if I'm talking about 1, 4, 5, and 8, they're on the same side. They're both, all 4 on the left side, But they have to be in the same position of their cluster. So 1 is in the top left of its cluster. It's corresponding to 5 because it's also in the top left of its cluster. 2 is in the top right. 6 is in the top right. They are corresponding. 4 is corresponding to 8. 4 is in the bottom left of its cluster. So is 8, bottom left. And of course, 3 goes with 7. They have to be on the same side of the transversal. But I want you guys to realize one is an interior angle. The other one is an exterior angle. So it's kind of like the black sheep of the family. They're on inside and outside. All right. Same side. Okay, so consecutive interior, you might have a teacher, or if you are a teacher, you might be calling it same side interior. Consecutive interior and same side interior are the same thing. Now let's move on. All right, example number 2. It looks like we are about to classify the relationship between these. All right, so let's break this down to make it easy for your students. Okay, 4 and 5. First off, there's 4 and 5. And I want you guys to realize they are interior angles. They are between the two lines that the transversal intersects. So far, they're interior angles. Now, the only choices are same side interior or alternate interior. So ask yourself, are they on the same side of the transversal or on different sides of the transversal? Well, 4 is on the right of the transversal. 5 is on the left. That makes them alternate angles. So they are alternate interior. 3 and 7. All right, 3 is on the inside of these two lines. 7 is on the outside. Well, there's only one situation where that happens, and that is corresponding angles. These are corresponding angles. One is an innie, and one of them is an outie. All right, 3 and 5. Okay, so look, they're interior angles. 3 and 5 are both inside the two lines that the transversal intersects. That makes them interior. So now you got to ask yourself, are they on the same side of the transversal? Yeah, they're both on the left. That makes them same side interior, or you can call them consecutive interior. They are not alternate. So I don't care which one you put. You're going to put consecutive interior, same side interior. They are the same thing. Up here, the directions are consecutive interior. One and 8. All right, 1 and 8. They are outside these two lines. One is above, 8 is below the other one. That makes them exterior angles. And I want you guys to notice that 1 is on the left of the transversal, 8 is on the right of the transversal. That makes them alternate. These are alternate exterior angles. All right, example number 3. Okay, let's see. Identify the transversal. Okay, you guys, basically that's the line that they're both on. They are both on the transversal. Then you got to ask yourself what type they are. So we got to classify it like we did up here as either alternate interior, alternate exterior, corresponding or consecutive interior. All right, so let's go with 1 and 8. All right, so here's 1. It is at the corner of line D and line F. So D and F. And 8 at the corner of E and F. Well, I said F on both of them, so F is the transversal. All right, so 1 and 8. I want you guys to realize that this is your transversal. So this is the line that's crossing two lines, D and E. All right, so I'm looking between them, and I notice that 8 is the only one that's between them. 1 is not between them, and there's only one chance when one's an innie and one's an outie. All right, that is corresponding angles. All right, next one, transversal connecting 3 and 6. All right, here's 3. Here's 6. They are both on line G because 3 is at the corner of D and G, and 6 is at the corner of E and G. G is what I said both times. G is your transversal. All right, so G is a transversal. These are the two lines that it crosses, D and E. And I noticed that 3 is outside the two angles, so 3 is exterior. 6 is also outside D and E, which makes it exterior. So 3 is on the right of G, 6 is on the left of G. That makes them alternate exterior. Transversal connecting 6 and 7. All right, there's 6, there's 7. 6 is at the corner of E and G. 7's at the corner of E and F. And which letter did I say both times? That's your transversal. Now I said G and F. So you're looking, are they between G and F or are they not between? Well, 6 and 7, they are between line G and line F. That makes them interior. And you guys, they're both below the transversal E. That makes them on the same side of the transversal. So either put same side interior or you can put consecutive interior. You guys need another example, you can go online and get that. All right. Okay, here it comes. The only time that these angles can be congruent is when the lines are parallel. Remember, on the ACT, they're going to have these little triangles to show they're parallel, or somewhere in the directions they may have the names of these two lines with a skinny 11 between them, and that's the symbol for parallel. All right, and if you're my students, I use the checkerboard technique or the lightning bolt technique to realize which ones are congruent to each other. There's a nifty little math antics video that does a great job for my visual students. But look at this. Angle 1 is obtuse. Angle 7, also obtuse. 1 jumps to 7 like a checkerboard, jumps over to 3, which is obtuse. 3 jumps to 5, which is obtuse. And they're all going to be equal to each other. So 1 and 7 are vertical, 3 and 5 are vertical. They're all obtuse. Those are equal angles, but that's when the lines are parallel. Same thing with 8, 2, 6, and 7. 8 jumps to 2 to 6. I think I said 7. It should be 4. 8, 2, 6, and 4. They're all acute angles, and they're all going to be equal to each other. And again, that only happens when the lines are parallel to one another. So if you have a question about that, make sure you ask me, ask your teacher. If you are a teacher and you're still having issue, like I said, Math Index has a really good visual aid. Just look up parallel lines cut by transversal. All right, let's go on. All right, so if you need another couple of examples or proofs and stuff, you can go on and look in that. And I'm going to move to the next page, get to my next example. Okay, you guys, so we're going to use the theorems about parallel lines. So it looks like I've got, excuse me, okay, this is line J, line H are parallel, and I is going to be parallel to K. Let me close this out. Parallel. All right, it tells me angle 1, which is this little acute angle right here at the corner of H and I, is 42. And they want me to find angle 7. All right, so listen. Angle 1 is acute. So is 3. So is 5. So is 7. They are all equal to each other. They are congruent angles. So if angle 1 is 42, the angle 3, 5, and 7 are all 42 degrees. So I'm going to put 42, and I'm come over here and get my little degree mark. All right, so angle 7 is 42 degrees. Okay. What's up next? Okay, we got a check here. Okay, it says Dennis Avenue and State Road are parallel streets. There's State Road. There's Dennis Avenue. Looks like Newport is going to be our transversal. Let's see here. Angle 3 is 62. Well, 3, 1, 2, and 4 are all acute angles. There's my checkerboard. They jump over. 3 and 1 are vertical angles. 1 and 2 are alternate interior. 2 and 4 are vertical angles. They're all equal to each other. So if angle 3 is 62, so is angle 4, 62 degrees. Looks like I got a little degree mark right there. All right, example 5. All right, first I'm going to notice that J and K are marked parallel. L is my transversal. What that means to me is 1, 4, 5, and 8 are all equal. 2, 3, 6, and 7 are all equal. All right, so there's angle 3, which is 4x plus 7. It's obtuse. Angle 6, 5x minus 13, also obtuse. They're equal to each other because remember 2, 3, 6, and 7 are all equal. They are congruent. All right, so these are 3 and 6 are between the two J and K lines. That makes them interior. 3 is above the transversal L. 6 is below the transversal L. That makes them alternate. So these are alternate interior. All right, that makes them congruent. We're going to set them equal to each other and solve. All right. So we got to find Y, and it gives me angle 8 and angle 3. Well, there's angle 8, which is acute. Angle 3 is obtuse. Aha, these are not equal to each other because 8, 5, 4, and 1 are equal to each other. 1, 4, 5, and 8. These are all your acute angles. So 8 is acute, 3 is obtuse, not equal to each other. So I bet we're going to do a little substitution. So 5 and 8. Well, there's 5 and 8. 5 and 8 are vertical angles. And 5 would be congruent to 8 because definition of vertical angles. All right, so 5 and 8. Looks like angle 5 would be 68 degrees because angle 8 is 68 degrees. All right, so they're supplementary, going back to 3 and 5 not being equal to each other, because it looks like I'm doing a little proof here. 8 and 5 are vertical, so whatever 8 is, 5 is, and these are supplementary because consecutive angles are 180 degrees. They're supplementary angles. All right, so it looks like I need to realize that 5 and 3 are supplementary by the supplementary angles theorem. And they're going to add up to be 180 degrees. So if angle 3, get back over here. Let's see, where are they going with this? Angle 3 is 3y minus 2. So let me put it here. And angle 5 is 68 degrees. All right. Okay, I see what they're doing. They are combining the -2 and the 68 as like terms. So -2 plus 68 is 66. All right, so now they're going to subtract 66 to the other side. So 180 minus 66, and they're going to divide by 3. And let's see, 180, I'm going to need a calculator, aren't I? 180 minus 66, and then divide by 3. All right, that's 114. The opposite of multiplying is divide, so it looks like it's going to be 38 degrees. All right. So you guys have any questions about that, ask me. Ask your teacher. Supplementary means they add up to be 180. So if you want to check your work, just ask yourself, hey, do these, when I plug back in, add up to be 180 degrees? All right, so let's move on. Okay, it looks like we are done with the last example. So I'm going to stop right here, and I'm going to let that practice be with you guys. Make sure you ask your teacher, okay? That's why we make the big bucks being a teacher. We answer all of your questions. All right, good luck, you guys. Let me know if you have any issues.